Intercepts and asymptotes. We're going to be doing a lot of curve sketching. We need to be able to find these, and there's going to be something interesting going on with your asymptotes. So quick review. To find the x-intercept, you let y equal 0. When we let y equal 0, to clean out that denominator, we'll multiply both sides by x plus 1. When we do that, the left-hand side is 1, the right-hand side is 2. Those are not equal to each other, so it's impossible to make y equal 0. Therefore, no x-intercept. To find the y-intercept, let x equal 0. We'll take the same function, put 0 in for x, our answer is 2. Vertical asymptote, you ask what makes the denominator equal 0. So we take the same function and we ask what would make the denominator equal 0. The answer for that would be -1. So we have a vertical asymptote at -1. Horizontal is the limit as x approaches infinity for the function. But this is our function. We'll calculate this limit. I'm getting 2 over infinity plus 1. That's really 2 over infinity. So 2 divided by an enormous number, that's 0. So all of this should be familiar. What's not familiar? If your horizontal asymptote is equal to infinity, we have something called an other asymptote. Because you're not approaching a number, so you're not flattening out. Something else is going on. So step 5 only happens when the limit approaches infinity. Then we have to say, well, what part of the function gave us the infinity? For example, x squared plus 1 over x. If you calculate the limit as we approach infinity, this part goes to 0, and this gives us an answer of infinity. So where is the infinity coming from? It's coming from x squared. So the other asymptote is y equals x squared. So what does that look like? The blue graph is x squared plus 1 over x. And what is it approaching? It's approaching this line. And on this side, this line. And that happens to be the graph of x squared. So it's not a horizontal asymptote. It's not doing this. It's actually approaching a curved line instead. So these are known as other or slant asymptotes. So slant asymptotes or other asymptotes. Slant asymptotes are usually ones that go like this. Other ones, curved lines. All right, so let's do some more of those asymptotes. We said we calculate the limit as we approach infinity. This goes to 0. This goes to infinity. So we're approaching infinity. That says we're not horizontal. What gave us the infinity? 3x did, so that's the other asymptote. If you'd like to know what that looks like, 3x plus 1 over x squared is the blue graph. 3x is this graph, and you can see that your blue graph is approaching that asymptote. Let's try another. Limit as x approaches infinity. When you approach infinity, the rule was divide by the highest power of x taken from the bottom. We're going to divide everything by x. We can reduce that. That would give us x to the power 1 on top. That would give us a 1 and a 1 over x. This will go to 0. This will become 1, and we still get infinity. Now, unfortunately, this doesn't look like the other questions. This is a fraction, and the other was a collection of terms, so we have to make it look like it did before. So what we're going to do is divide x plus 1 into 2x squared. What do I mean by that? Divide x plus 1 into 2x squared. Okay, what multiplies to give us 2x squared? 2x does. 1 times 2x is 2x. What was our x term to begin with? There wasn't one. So that'll balance with a minus 2x. What did you multiply x by to get minus 2x? You get minus 2. That gives us a minus 2. Now, there was no number there, so that would balance with a 2. This term is our remainder. So what we've learned is that when you divide 2x squared over x plus 1, it goes in evenly, 2x minus 2 times. but there's a remainder of 2. So the 2 remains over that fraction because we weren't able to divide it out. So this expression is the same as this one. And why do we care? It's much easier to calculate the asymptote from this side. So let's make that look a little prettier to see what's going on. So this is what we divided out, and we said we had to make these two terms equal 0 because there was no number term up here. That's our remainder, and this is how it looks. Went in evenly, 2x minus 2 times. Had a remainder of 2, the 2 remains over the fraction. Now when you calculate the limit as x approaches infinity, this will go to 0. So what gave us the infinity? Again, that's the part that gives us 0. This then is the asymptote. What does that look like? The original graph, 2x squared over x plus 1 is in blue. 2x minus 2 is this line. So again, why did we have to do it? There are 2 different ways of writing these fractions. 1 and 2. They're the same thing, just it's much easier to find out what gave us the infinity when it's written this way. So how are you going to recognize to do this? Check out that exponent compared to this one. If the one in the top is bigger or equal to the one in the bottom, you're going to have to do this. So let's go through an entire question. Find the intercepts and asymptotes for y equals x cubed minus 8 over x plus 3. X-intercept, let y equal 0. Multiply both sides by x plus 3 to clean out that fraction. That will give us x cubed minus 8 on the right and 0 on the left. Bring the 8 over. And what cubes to give you 8? 2 does. Y-intercept, let x equal 0. Negative 8 over 3. Vertical asymptote, what makes the denominator equal 0? Negative 3. Horizontal, take the limit as x approaches infinity. That means dividing by the highest power of x from the bottom. And that will still give us an infinity. This one goes to 0. This one goes to 0. So we end up with infinity over 1, which is infinity. But this, unfortunately, is not an expression where it's easy to find out what gave us infinity. So we're going to have to divide x plus 3 into x cubed minus 8. Okay, here we go. What multiplies by x to give us x cubed? That would give us a 3x squared. What is the x squared term? I don't see one. So that will give us no x squareds. When we combine these two terms. So this would be minus 3x, giving us minus 9x here. What is the x term originally? There isn't one of those either. Gives a 9 there and a 27 here. We wanted to end up with negative 8. I think I'm going to have to subtract 35 to make that happen. So that is our remainder. So when you write your expression, y equals x cubed minus 8 over x plus 3, it can be written as x squared minus 3x plus 9 with a remainder of minus 35, and that remainder remains over the denominator of x plus 3. Then we can figure out what the horizontal asymptote is. Okay, I'm going to put that so it looks nicer and you can see what's happening. So there's our remainder. We can write it this way. Take the limit as x approaches infinity, and you'll find out this is what gave us infinity, because this section goes to 0. Now, if you would like a slightly quicker way of doing this, we recognize that this is a higher degree or equal to the one in the bottom. We do with the backwards box, and there's our asymptote. If you'd like to know what the graph looks like, the blue is the original one. That's the x cubed minus 8 over x plus 3. And it's approaching this asymptote of x squared minus 3x plus 9. And you can do the same thing for trig. Here we go. X-intercept, let y equal 0. I think I'd bring cosine over, or sine, doesn't matter. Then I'm going to divide by cos. Why am I doing that? If I divide by cos, I can combine sine and cos into tangent. Why didn't we divide by sine? If we did, we would have had cotangent, and we're just not as good at it. When does tangent equal -1? I'm going to think about 1 first. Tangent equals 1 at an angle of pi over 4. So tangent will equal -1 at what angles? It would be this quadrant and this quadrant. We know the reference angle is pi over 4. So reference angle, angle between terminal arm and closest x-axis. And then this angle is 3 pi over 4. And if you go all the way around, that would give us 7 pi over 4. So x-intercepts of pi over 4 and 7 pi over 4. Y-intercept, we'll let x equal 0. All right, how do you calculate the sine and cosine of 0? We're at this point right here. That's the point 1, 0. So that's our x and our y. We have a circle of radius 1. Sine is y over r. So that's 0 over 1. Cosine is x over r. That's 1 over 1. I think our answer for that is 1. Vertical asymptote. You make your denominator. I don't see one. No denominator, no vertical asymptote. So there's no horizontal asymptote either. So we're only looking for asymptotes when we have rational functions, meaning something in the denominator. Does that mean trig never has them? Well, if you think about tangent being sine over cosine, it is possible to have things in the denominator. So just be careful. If you don't see a denominator, though, that's a happy moment. You don't have to worry about any asymptotes. Okay, your job, we're on lesson 2, 22 questions. Practice them, get good at this, and then it'll make the graphing easier.